So I wanted to go over a related rates example. This was one from the 2016 exam, not too long ago. And they give you a funnel and they tell you the function that represents its radius and ask you a few questions. First question is find the average value of the radius, which is a simple integral, but not on this year's exam. You don't have to know average value, so we'll ignore that. Then the volume of the funnel. That would you can do that just by adding up all these disks. Not part of the exam this year, so we're going to ignore that. Finally, C is what I was looking for. C is your related rates question. And the big giveaway about it being a related rates question is when you read it, you'll see that, well, rate is a big giveaway. Inches per second is a big giveaway. So this is going to require finding a equation that relates to the variables and then differentiating it with respect to t to make it a related rates question. So let's look at this. I would identify all the variables first. It says at the instant when the height of the liquid is h equals 3. So we're saying h equals 3. That's not a constant. It's just saying we're looking at this exactly when h equals 3. H is getting smaller because water is leaking out, draining from the bottom. It says the radius of the surface is decreasing at a rate of 1/5 inches per second. So the radius is decreasing at a rate. That is a rate. So it's not r, it's how dr is changing with respect to t. And that equals 1/5 inches per second. Now that's a giveaway. Inches per second also gives away that it's dr dt because inches is the measurement radius and seconds is the measurement for time. One more thing, it says the radius is decreasing. So this 1/5 is negative. It's getting smaller. So finally at this instant, what is the rate at which the height is changing? The rate at which the height is changing with respect to time. So that's dh dt because they're looking for a rate. So now you have to look for the equation that relates the two variables we have, h and r. Either the equation will be given, like it actually is here, or it might be some easy geometric formula, like if a disk was increasing, you may be expected to use area equals pi r squared and use that. But here they give us the equation r equals 1/20 times the quantity 3 plus h squared. So that's the regular equation. Now we have to make it a rates equation by differentiating with respect to time. Now it's all implicit because there's no variable for t here. So the derivative of r is dr dt. The derivative of the right-hand side, well, 1/20 is a constant. We can ignore it. The derivative of 3 is 0 with respect to anything. And the derivative of h squared is a chain rule. Derivative of the outside, leave the inside alone, so 2h to the first, then times the derivative of the inside, which is h. So that would be dh, derivative of h, with respect to t. So this is dr dt equals 1/10 h dh. Now you just plug everything in. Now, if you find that you don't have enough things to plug in, you're missing something, go back to the paragraph and see if that gives you any clues on what you're missing. But in this case, DRDT is given, negative 1 over 5. H is given to be 3. And DHDT is what we're looking for. So we're in good shape. We have negative 1/5 equals 3/10 DHDT. Multiply both sides by 10 over 3. And you're done. So there's never any need to simplify this. I know you know it's the answer is negative 2/3, I believe, if you simplify, but you might make a mistake and lose the point. So this is fine. The last thing I want to make sure I do is check to see if they asked for units. Because if they do, that's going to be a point. What is the rate of change of the height with respect to time? It doesn't say use the proper units, or so it didn't ask for units. I'm not going to give units. So I'm satisfied with this answer right here. That's it.